How are we all going? You're back with Jono for another quick math lesson. Today we're going to look at how to add and subtract surds. Really, you've already done all this work with your algebraic techniques, but surds just look a little bit harder. We're going to find this okay. Just to start off, we're going to illustrate some of these points. So root 2 is equal to 1.414 ... Just some number. What's really important is that this is going to highlight why we can't just add the whole numbers under a square root sign. So here where we've got root 2 plus root 2, a very common mistake students make is to go, oh well, I can just add those two whole numbers underneath the surd. That's basically what we did for multiplication, which would become root 4. Root 4 is equal to 2. That could be right. But from that last example where we wrote out what root 2 is, we've got 1.414 plus 1.414. That definitely does not equal 2. So this just highlights that we're not able to add these like we normally would. So the rule is that we can't add or subtract surds unless they are like. So this is a combination of both algebra, where you have to have the same letter in order to add and subtract them, or even kind of like fractions where you have to change the denominator in order to start adding and subtracting. Kind of like how a plus a is equal to 2a, but a plus b is not equal to 2ab. These are totally different things. So what we're saying is that when we add surds, it's how many groups of the surds we have. So in 2 plus 2, I'm saying that I have root 2 2 times, or root 2 multiplied by 2. This just ends up as 2 root 2, and that's as simple as we can get it. So if you are looking for a general rule, this is it. Only if the surds are the same can we add them or subtract them, and the number out the front is just telling us how many groups we actually have. So with a couple of examples, if I've got 3 root 5 plus 2 root 5, how many groups of root 5 do I have? That is just 5 root 5. So I'm able to add the numbers out the front just like normal, and then I keep that surd exactly the same as I manipulate it. In another example, 7 root 11 minus 3 root 11, I just subtract these numbers out the front like normal, which is 4, and then I don't change the surd, so I'm left with 4 root 11. Very similar to algebra, if these underneath the square root signs are different, you cannot touch them. So the big common mistake I would see here is that students would minus the 3 and minus 2, which gives 1, and then they would go, oh, root 6 minus root 5, that must be root 1, so that's equal to 1 root 1, which is equal to 1. That's way too simple for a question that comes from this. We know it can't be right because both of these surds are irrational numbers that go on forever and ever and ever. To come out with a whole number of 1 doesn't make any sense. So all you have to do is leave it as the question. That's fully correct. So just because it's there doesn't mean you have to manipulate it. Only if the surds are exactly the same can you start to do addition and subtraction. Thanks so much, guys, and I'll see you later. Just a quick reminder, there are some free worksheets linked in the description below, as well as the notes from this video. If you've got a second, please like, comment, and subscribe to Quick Math for more content every day. Thanks so much. Have a good one.